So what we're going to do now is we're going to talk about the next steps in our concurrency and synchronization elements of this particular module. And what we're going to do here is we're going to talk about various Android concurrency idioms and understand some of the programming mechanisms that are involved in those idioms, the pieces, the building blocks that are provided by Android. Now, if you recall what we talked about in the previous parts of this module, we primarily focused on the Java mechanisms. So we talked about Java threads, we talked about Java synchronization in terms of the implicit monitors or implicit monitor object that occurs in every Java object. I talked about the monitor object pattern and illustrated how that could be applied in Android and so on and so forth. What we're about to do now is we're about to move from Java general purpose discussions to Android specific things. And then the next part of this module will go into lots of detail about how to program this stuff. This just gives you an idea of the pieces. First of all, why do we need Android-specific concurrency mechanisms? Why isn't it sufficient just to use the stuff that comes out of the Java toolkit out of the box? Well, a couple reasons, some of which we talked about before. There's this thing in Android called the application not responding, or ANR dialog. And it's generated if the user interface thread doesn't respond quickly, where quickly is defined in 3 to 5 seconds. If it gets blocked for any length of time, the ANR dialog shows up, and you get a chance to shut things down. Take a look at this link for more information about ANRs. And something else we talked about, you can't have non-user interface threads, or thread, accessing the widgets, the ways of visualizing various lists and other components and views from anything other than the user interface thread. You can't have background threads that are accessing the user interface. So because of those reasons, we have to do something else. And there's a nice article here at this link that talks a bit about the design considerations that lead Android down this particular path. So to make things more amenable to the kinds of constraints that Android has, there's a set of very specific idioms, which are really patterns that are Android specific. An idiom is a pattern that's specific to a particular context or language or framework or operating environment or middleware or whatnot. And these are used to be able to allow certain computations to run in the background where they're unfettered from having to worry about these ANRs. And then when they compute something that's of interest to be displayed, they can communicate with the foreground thread, with the UI thread, or sometimes called the main thread of control. And if you take a look at this link, you'll see a description about the UI thread and how to communicate with the UI thread and so on. So the typical ways of doing this, one approach involves some things called handlers and runnables, or handlers and messages. So handlers, messages, and runnables, that's one pile of things you can use to communicate from background threads to a foreground thread, or actually from the foreground thread to itself for various reasons, if you want to defer processing of certain things. And then there's another thing, and there's a nice article that appears here that talks about all this stuff. And then the other approach is called an AsyncTask. We've talked a bit about an AsyncTask before, so I won't give you the long discussion of AsyncTasks, but you'll see some examples of how to program AsyncTasks. So those are the 2 or 3 common ways of doing things. Now, all of this stuff is actually built out of some mechanisms that Android provides as reusable classes, some of which you see on a regular basis, some of which are largely invisible to you. So the first thing we're going to look at here is the Android looper class, which is largely invisible to you unless you're doing some more sophisticated uses of threading besides what comes out of the box. So a looper provides a message queue to a thread of control. And there's only one looper allowed per thread. And later, next class, we'll talk about some of the mechanisms that Android uses to enforce that particular design rule. The UI thread is a looper. So the UI, not an is-a relationship, but it has a looper. And but be aware that you can have other non-UI threads that have loopers as well. So a UI thread has a looper for sure, but other threads can have loopers too. And take a look at this link for more information about what a looper is. The loopers.loop method runs a thread's main event loop. And this is basically what that event loop does. So the event loop's purpose is to wait for messages to come in and then dispatch them to the appropriate handlers of those messages. So let's take a look at how this is going to work. So if you were to take a look inside of the implementation of Looper, which I'll give you the link in a second to see where the source code is, and I strongly encourage you to do this, you would see that inside the Looper loop method, it does a bunch of stuff, and then what it does is it finally says, wait for the next thing to show up, or things to show up. And there's a method called next on something called a queue, and this goes down and actually blocks waiting for something to happen. And under the hood, it's doing some kind of I/O level waiting on a set of I/Os, a set of I/O handles. That's below the level that you typically care as an application developer, but the Android frameworks care a lot about that because that's how they take information from the touch screen or the various sensors and devices connected to the phone, like the network or Bluetooth or other kinds of things, and deliver that up to the application services that are running to do the work. Once you've gotten the next thing to do, then the looper's loop method goes ahead and dispatches the handler for that particular kind of looper. And we'll look later and see what handlers can do and what their behaviors will be like. Note, by the way, the inversion of control. If you ever look at how an Android application works, you don't see any of this stuff. If you write your garden variety Android application with an activity with methods like onCreate or onStart or onStop or whatever, you don't see any of this looping stuff. It's all hidden for you in the bowels of the Android framework or frameworks, and it waits for all this stuff deep down inside, and then it dispatches stuff that ends up calling back to methods that you typically write or that you're reusing and customizing in some way. Here's the place to go to look to find the source code for all of this stuff. Again, I strongly encourage you to take a look at it. It's really quite interesting to see how it works under the hood. We will talk about this stuff next class on Wednesday. I'll give you a peek inside of what it looks like internally. By default, a thread, a Java thread that Android gets by default, doesn't have a message loop or a message queue associated with it. So if you want one, then here's how you need to create one. So what you need to do, and this is an example I'm taking right out of the documentation for the looper that comes with Android, you have to do two things. You have to call looper.prepare, which is clearly a static method. You have to call that in the thread that you want to become a looper. And here's some more discussion about that. And then you go ahead and you create one or more handlers to be able to handle these things in various ways. And then you go ahead and call the looper.loop method. And that's what actually goes ahead and runs the event loop. So if you go back here a little bit, you'll see that that will go ahead and call this method here, which waits for events to show up and then dispatches them. So again, you can see the nice inversion of control that's happening here. But calling looper.prepare and looper.loop are essential. And we'll talk more about how that works when we get further along in the pattern discussion. There's a helper class that is called Handler thread that's part of Android. And you can use this to create a thread that automatically has a looper as part of it, as its very nature. So here's an example of how this works. We have handler thread, as you can see here, that extends thread. It defines a looper, and it has a run method that says looper.prepare, does some magic. And this is actually the template method pattern that we talked about before. So run is a template method. It calls to prepare, and it calls to loop. Those are sort of the fixed steps in the algorithm. And then it also has this onLooper prepared hook method, which is the primitive method or the hook method in the template method pattern. And you can customize this by subclassing from handler thread, and you can fill in whatever you want to do between the point when looper.prepare is called and looper.loop is called. So that's just a good old template method pattern showing up in Android to help give you that hook to add in your handlers that you want at that point. You can take a look at this for more information on handler thread. The start method still has to be called. You are still responsible for calling start on a handler thread to get its run method to run to do the things that we just looked at here. And if you want to look at the source code, it's all right there. Any questions about handlers and so on? Pretty cool stuff. Okay, the next topic, so that was the looper. You really don't see loopers a whole lot. If you're seeing loopers, it's because you're mucking around with Android framework level internals. If you need to use a looper, you can probably use handler thread and customize that with the template method pattern and so on. So you probably won't see loopers a lot, but they're very important, and we'll talk next class about how they use various patterns, such as the thread-specific storage pattern, in order to enforce certain properties, like this constraint that you can only have one looper per thread. We'll see how that all works. A class that you are likely to run across, however, and you see it all throughout Android code, is the handler class. So most interactions to a message loop, the message loop in Android, is done through handlers. And a handler does a couple things. It allows you to send and process messages, and it allows you to also have send and process or post runnable objects. And you can create those things that may be actually running in a different thread of control, and you could have them run in some other thread of control. There's a bunch of subtleties and interesting things that are going on here. We'll talk more about this as we talk through handlers. So one of the things to note here is that a handler belongs to the thread in which it was created. Very important thing to understand. I'll show you later how that's enforced. It's enforced through the thread-specific storage pattern. When you create a handler, the handler knows, either because it implicitly took whatever thread it was created in and uses that as its owner thread, or you can pass it a looper and it'll be part of that looper. You can control how these handlers start up. And then other threads that may be background threads that are running in distinction from the UI thread or the main thread or just some other thread, they can communicate with another thread by passing messages or runnables through handlers to another thread. And we'll see later that this particular way of arranging things goes by a variety of different patterns. We'll talk about the active object pattern. We'll talk about the half sync, half async pattern. These are all great patterns, post-it2 patterns that exist and are used quite extensively throughout Android. So take a look at this link for more information about what a handler is. Every handler object is associated with a single thread and that thread's message queue. So there's a bunch of different things that are going on here. So here's the handler class. This is what you get as part of Android. And one of the things you see if you look at the implementation, there's an abstract method called handle message. And if you want to pass messages through a handler to be handled, you have to subclass from handler and fill in the handle message hook method. There's other ways to do it, but that's one way to do it. When you create a new handler, it's bound to the looper thread, and thus the message queue of that looper thread, of the thread where it's created. And this is kind of how it works. So if you were to take a look at the handler constructor, which you're welcome to do because you have the source code for all this stuff, you'll see the first thing it does is it checks to see whether or not it's running in a looper context, and if not, it bails out. And if it is running in a looper context, it grabs the queue that goes along with the looper that's associated with that thread of control. And from that point onwards, as people send messages or post runnables to that handler, they will end up being stuck onto the message queue, and they'll pop out and be processed in the thread of control that is owning that particular handler. So now we're back into the looper context, and we're dispatching callbacks in terms of what these things do under the hood. So it's kind of cool. You're kind of calling these things on the handlers, and then they're making sure it gets tucked into the right threads, right loopers threads message queue, so that that main thread, that looper thread, can pick them off and do the processing on them at the appropriate time. And we'll see that time actually plays a big role in all this stuff. So here are some of the capabilities of a handler. One thing a handler can do is you can use it to send messages and post runnables. We're going to talk shortly about the differences between messages and runnables. But the long and the short of it is you can pass these things in from one thread to another thread where they get processed. And the thread's message queue can be used to enqueue these things up and schedule them for future execution. The handler also implements thread-safe, synchronized processing of these messages, either in one thread or a different thread. The key thing to remember is you can write applications in Android that use the looper and use the handlers and use the sending and posting and so on, but only have one thread of control. There's no need to have multiple threads. You can have one thread of control, and if there's something that needs to be done asynchronously in the future, you can put it onto the message queue of the main thread's looper, the UI thread, and it'll just get processed when its turn comes to run. If you take a look, you can take a look at the source code for all this stuff. Again, it's very instructive to take a look at it. It's really not very hard to understand. It's very easy to see how the pieces fit together. And we'll talk later about some other things. There's a number of handler methods that are associated with runnables. These are things that can be used for either one thread to post runnables to itself or one thread to post runnables to another thread through a handler. And the methods are post, post at time, and post delayed. And so there's a bunch of different semantics. The post method simply takes a runnable and puts it into the message queue, so it'll be dispatched by calling its run method later in the main thread or the looper thread that you posted it to. Post at time will run at a specific time in the future, and post delayed runs at a specific amount of time after a specific amount of time elapses. So the main difference there is sort of absolute time versus relative time. And the different ways to control those things. Again, more information available there. There's also a set of methods that handlers have for being able to send messages. We'll talk shortly about message versus posting a runnable. They're different kinds of things intended to be used for different kinds of purposes. There's a bunch of different send operations. There's send message that you can use to put the message in the queue immediately. And there's send message at front of queue, which puts the message at the front of the queue as opposed to the back of the queue. By default, it goes to the back of the queue. There's send message at time and send message delayed that go ahead and stick things into the queue based on the time relationships that you identify when you pass the thing in. And all these things are used in various combinations for all kinds of interesting ways of deferring computation to take place in the future. So to summarize this particular discussion, Android applications have this UI thread. The UI thread is a looper, or it has a looper. Application components in the same process use the same UI thread. So you can have user interactions, things like interactions that take place between user objects, the system callbacks. So if the battery's low or there's some kind of alert that happens, that can be dispatched through these threads. The various lifecycle methods on activities and services, those are handled through the UI thread, and so on and so forth. Remember, don't access your widgets from anything other than the non-UI thread, and don't block the UI thread, so use these other mechanisms to do that. And essentially, when you need to communicate, use handlers and messages, or handlers and runnables, and you can also use async tasks that we'll talk about in just a second. OK. Any questions about any of that stuff? All right. Next section kind of picks up where the last one left off. So the last one was really more about the building block pieces that Android provides in order to be able to implement these different concurrency mechanisms, these different models of concurrency. We're now going to talk more about how to program these things. And we're going to look at three of them: handlers and runnables, handlers and messages, and async tasks. OK, so let's start by talking about programming with handlers and runnables. So this is actually really easy to program. What you typically do is you end up creating a runnable, and it's often done by something as simple as what I'm showing you here in just a snippet of code. We'll look at more detailed code in a second. But in a snippet of code, we're going to go ahead and create an anonymous runnable with an anonymous inner class that implements the run hook method with some code in it. And we're going to go ahead and post this to a handler. And as you saw before, what happens is that causes this thing to be turned into a message, and it gets stuck into the message queue. And then at some point later on, the looper framework comes around, gets that particular message out of the looper environment, and it does some little magic downcast kinds of things, realizes this is actually a runnable, not just a message, and then it goes ahead and extracts out the appropriate piece and then calls the run method that gets dispatched that was originally implemented from another thread, but it gets called in the main thread's user interface thread. Any questions about that? So pretty cool, pretty straightforward. Here is some code that illustrates how this stuff works. And in the interest of time, I probably won't run this example in my Eclipse environment. If I was to run the example in the Eclipse environment, you would see that there'd be a screen, and I would click on load icon, and it would use this mechanism to load an image. And that's what I'm showing you here. So if you take a look at this thing, we'll see that we have a simple threading example that extends activity, and it creates a new handler. Notice that this thing is created in the UI thread, because that's where the activities run in the UI thread. When the onCreate method gets called, a bunch of things take place here. and there's a method that's set up called, it gets connected to new set on click listener. And when you click the button, the load icon button, what will happen here is that the on click hook method of this thing turns around, makes a new thread, creates an object that's a runnable that's going to run in the context of that thread, and starts that thread. And notice it passes in the resource ID of the icon that we want to display. So all of the stuff I just showed you here is going to happen in response to a click in the main thread of control, as based in a callback in the activity. Well, the onCreate creates this, and then later there'll be a callback in the main thread of control to call back the onClick listener method, the onClick method of the onClick listener. Here's the load icon class. As you can see here, load icon is what's passed to the thread. That means it has to be a runnable. So the load icon constructor simply caches away the resource ID. And once this thread is started up and is running in the background, then when it's called, it'll go ahead and it will decode the resource. So it goes ahead and takes the resource ID that uniquely identifies that particular image, that particular bitmap, and it goes ahead and decodes it, turns it into a bitmap. And I can see I have a, should be over here like that. And then once we've done that, we go ahead and we say, handle, please post this newly created runnable object with a run method that's going to go ahead and set that image bitmap to the thing that was defined here on the image view that was defined back over here as a private element of our activity subclass. So we're going to create a new runnable. We're going to post it in the message queue, and that will then pop up later when the time is right, and that's what gets dispatched. The run method gets called back, and notice when that run method gets called back, what we do is we set the bitmap to be whatever we decoded from the resource ID that we had gotten from the Android resource file, the values file. Okay, any questions about what's going on there? Yeah?
Is that an inner class then?
Yeah. Yep. Yeah, you can see this is very common Android Java-esque type of programming where you're sort of magically making a new object on the fly with a method, and that guy kind of lives for a while and it waits till all the references are gone away and it disappears and so on. So a very common Android programming construct. The key thing to notice here is that there's not much going on. I mean, it's really localized. It's really easy to understand for the most part once you understand how the relationship occurs between the various parts. There are a number of different ways to post runnables to the user interface thread. So we just looked at one where you created an explicit handle and then you went ahead and posted to that. There's other ways to do it as well. Things like an image view, as you can see here, an image view actually has a post method as well. So if you're running in any thread of control and you want to post a runnable to an image view that's going to actually get executed in the main thread, the UI thread, because remember you can't run widgets like image view from anything other than the main thread, all you have to do is make your runnables and post them to the image view objects, which inherit from image, which have a post message, which ends up feeding things into that event queue that's managed by the looper thread for the user interface. So that's one way to do it. Another way to do it is there's another method that's called run on UI thread. And the run on UI thread is something that comes from the activity class. And so if you're in another thread of control and you want to be able to tell an activity to process some message in its main activity thread, the main UI thread, you can call run on UI thread and pass it a runnable. Any questions about that? So there's just a couple different ways that don't require you to create an explicit handler in order to get things to run in the main thread of control. Okay, so that's basically runnables. Real straightforward, real easy to program. The other approach is handler and messages. So what you do here, there are a couple different steps. You start by extending the handler class and overriding the handle message hook method. So you can see here, and in fact we can also do the same anonymous inner class trick here as well. We can say I want to make a new handler that has a new handle message method, and as you can see we don't define a specific class to do that. We make an anonymous inner class to do that. And then you can go ahead and set the various fields of that message. And you can do a variety of different things. You can set arg1 and arg2. I'll explain what we're doing here in a second when we look at the code. And there's some other things you can pass along with this as well. You can look at the documentation to learn more about this. There's a lot of different ways of making messages from handlers. And then once you go ahead and send this message, then it'll turn around and be processed in the main thread of control, just like we saw before. And what will happen here is it'll end up calling back the handle message hook method, and then you typically switch on the type of message it is, which is what this what field is. In this particular case, you can see that if it's the progress bar visibility message, we do something. If it's something else, we do something else. So you can direct the various processing that takes place. So let's take a quick look at how you might actually write this code. So what we're going to do here is we're going to have a simple threading example that extends activity. We make ourselves a new handler. This is going to happen in the main thread of control, of course, because that's where the activity is going to run. Its handle message hook method will take a look at the message type, and depending on what it is, it'll do different things. So we're going to set the visibility, we're going to do a process update, we're going to set a bitmap, and so on and so forth. Here's the onCreate hook method. And as you can see in this particular case, when this guy gets called, we go ahead and set up a click listener, which creates a new load icon. We'll look at that in a second, which is a runnable, and it starts a thread. We pass in the resource ID of the icon. And then here is the run method of the load icon runnable. And you can see it's just doing a whole pile of things. If you actually look at the code, you'd see we have a progress bar, which just kind of shows how far along we are in processing the message. So we're going to send a bunch of different messages here. We're going to start out by obtaining a message that's going to make the progress bar visible. So we send that. And then we're going to go ahead and decode the resource. Remember, all this is running in a background thread. Then we're going to go ahead and send a bunch of progress update messages just to advance the progress bar. And then we're going to go ahead and obtain a message here. Oops, that shouldn't be 200. That should be 100. And then we're going to go ahead and set the bitmap message. And we're going to go ahead and send that to run at some time in the future. And then we're going to say turn off the progress bar and make it become invisible. So if you were to watch this application run, you'd see the progress bar comes on visible for just a few milliseconds, and then it downloads, or it decodes the resource, the icon, and then it goes away, and then it displays it. So that's basically how you would do handlers and messages. The third and final thing here is programming with AsyncTask. Again, we talked about the framework before, so I'm going to go through this pretty quickly. You typically use AsyncTask when you want to have long-running operations separated from the main thread, but you don't want people to have to fiddle around with messages and handlers and runnables and so on. Instead, AsyncTask is designed as a framework that encapsulates thread and handler. And it actually implements some really cool patterns like the template method pattern and some other stuff as well. I recommend you take a look at the source code. It's very complicated, real cool stuff, interesting design. The key thing to remember with the AsyncTask is that you have to inherit from AsyncTask to make your task, and you have to fill in a bunch of different kinds of template parameters that say different kinds of things about the values you expect to pass in and the value you expect to get back from certain operations. And so here we're going to have some methods like do in background, on progress update, on pre-execute, on post-execute, and so on and so forth. Here's the source code. So let's take a quick look and see how this might work. Once again, we're going to have our onCreate method, and you can see what it does is it sets a click listener, and when this click listener is called, it goes ahead and it calls load icon, which should actually be load icon, not load icon task. Does load icon dot execute, and the execute is the hook into, it's the template method into the async task. And here's the actual async task. So load icon is a async task that's customized for the parameters we need to be able to pass. It's got an on pre-execute method. This gets called in the main thread of control before we do anything in the background. What we do here is we just make the progress bar visible. and then we run a background thread. This runs in a separate thread of control, not the UI thread. That guy decodes the bitmap, and then it's going to update progress. Just to illustrate how you do this, you say publish progress. That will end up calling this onProgressUpdate method, which runs in the UI thread. So you could do things like update the status bar in the UI thread as progress is taking place. And then after the doInBackground method returns, and as you can see, doInBackground returns the bitmap object that we had created when we decoded the resource ID. That gets passed into onPostExecute as the result. We make the progress bar invisible, and then we go ahead and set the bitmap to be the one we just decoded on the image view. OnPostExecute runs after doInBackground is done, and that executes in the main UI thread. So that's basically how AsyncTask works. OK, so to sort of summarize this stuff, posting runnables is very, very simple. There's not a lot involved there. But if you use runnables, you typically have to make lots of runnables. So sort of on the programming side, you have to use those anonymous inner classes, and each one might be different. Sending messages is a bit more complicated to program, but there's more things you can do with it. You're not just posting one thing. You can send a whole bunch of messages as sort of a conversation that you might have. So there's a bit more flexibility there, but it's more complicated. AsyncTask is by far the most complicated thing from an implementation point of view, because there's a lot of moving parts. But you don't really see that. That's hidden from you by the Android framework. You just see the methods like execute, which is the template method, and then onPreExecute, onPostExecute, doInBackground, onProgressUpdate, all those hook methods that you fill in. So that is arguably less efficient, but it's also very powerful, and a lot of the complexity is hidden from you. OK, any questions about those three different styles?